So hi everyone, I am Nasfijoy Duran together with Mr. Arnel Kitani from School of Engineering and Technology. So today we will be tackling about modeling, computers, and error analysis. So first of all, we are welcoming you all in this lecture 1. So without further ado, let's begin and let's have fun. So first, we'll be understanding what is modeling in general, and most specifically, what is mathematical modeling. So in mathematical modeling, we will be answering the questions what, why, and how. And also, in this lecture, we will be talked about the applications of mathematical modeling and its objectives.
Model is a miniature or abstract representation of something, a pattern of something to mean an example for imitation or emulation, a representation used to visualize something.
We go through, we always hear the word model, and model is nothing but a replication of something that can be real. As stated, model is associated with the word miniature, abstract representation, or a pattern of something. We continue, there is different examples of mathematical modeling that are associated with. So first, we have physical models that includes the model airplane, model of solar system, humanoid robot, building, and bridge. We also have a schematic models. It provides means of visualizing system structure. First, we have the organization charts, process charts, graphs, geographical map, diagrams. Above mentions are some of the examples of mathematical modeling that proves how it is important. So what is mathematical model? Mathematical model is a representation of the behavior of real objects and phenomena in mathematical language. When we hear the word mathematics, all the words that comes into our mind are called mathematical language. We have the plus, minus, times, divide, algebraic expressions, square root, and etc. Are symbolic representation of mathematical language. So we will elaborate those into a bigger scale. So we have here algebraic equations, differential equations, integral equations, algorithms, formulae, and theorems. To understand why we do mathematical modeling, we know that all of us have been performing mathematical modeling knowingly or unknowingly since our school days. So whatever school mathematics level you studied, whatever formulas and equation you studied, ultimately they are nothing but mathematical model. Many laws of nature are beautifully captured and explained with the help of mathematics. And even if you aside the static sense of mathematics, you will understand that there are many quantities in performing mathematical modeling. For example, there are fields of science and technology today which in touch with mathematics, and moreover, the best way to quantify abstract behavior of some real phenomena is the help of mathematics or mathematical modeling. Quantification of some abstract behaviors, hence abstract means that cannot be measured or cannot be quantified, but mathematical model make that possible. So there are many advantage of performing mathematical modeling.
Objectives of mathematical modeling. Mathematical modeling is a process that uses the language of mathematics to analyze, make predictions, provide insight of real-world phenomena.
Here are some applications of mathematical modeling. Done in explaining modeling or mathematical modeling. So we are now ready to explain what is conservation law.
What is conversation law? A conversation principle states that the rate at which a quantity changes has to be accounted by how much of the substance goes into the system and how much of it goes out of the system.
We have here the following conservation laws according to classical physics. First, we have conservation of mass, conservation of energy, conservation of charge, conservation of linear momentum, conservation of angular momentum. Done explaining conservation law, so we are now ready to move on our next subtopic, which is MATLAB environment.
Lab environment is a computer program that provides the use with environment in this environment for performing many types of calculations.
MATLAB environment also provides a very nice tool to implement numerical methods. It is the most common way to operate MATLAB is by entering commands one at a time in command window. MATLAB uses the three primary windows, which is the command window, graphics window, and the edit window. Command windows used to enter commands and data, and graphic windows used to display plots and graphs, and edit window used to create and edit M files.
Assignment. It refers to assigning values to variable names. This results in the storage of the values in the memory location corresponding to the variable name.
So we have four types in assigning values to variable names. First we have scalars. Second, we have the arrays, vector, and matrices. Third, we have the colon operator. And the last, we have the linspace and the log space function. So we have scalars. The assignment of values to scalar variables is similar to the other computer languages. So in scalars, you can type several commands on the same line by separating them with the commas or semicolon. So if you separate them with commas, they will displayed, and if you use the semicolon, they will not. So next, we have the arrays, vector, and matrices. So an arrays is a collection of values that are represented by a single variable name. So we have one-dimensional arrays are called vector. Two-dimensional arrays are called matrices. So brackets are used to enter arrays in the command mode.
The colon operator. The colon operator is a principal tool for creating and manipulating arrays.
Moreover, if a colon is used to separate two numbers, MATLAB generates the number between them using an increment of 1. And if colons are used to separate three numbers, MATLAB generates the number between the first and the third number using an increment equal to the second number. Next, we have the linspace and the log space function. The linspace and log space function provide the other handy tools to generate vectors of space points. The linspace function generates a row vector of equally spaced points. Next, we have the another subtopic of MATLAB fundamentals, which is the mathematical operation. So mathematical operation with scalar quantities are handled in a straightforward manner, similar to the other computer languages. So we have the common operations. First, we have the exponentiation, negation, multiplication, and division, division, and addition and subtraction. So next subtopic is use of built-in function. Built-in function, these are those that came with MATLAB or are part of an add-on product. You typically don't have source code for built-in function and must treat them simple as black boxes. Also, one of the important properties of MATLAB's built-in function is that they will operate directly on vector and matrix quantities. Already another subtopic, which is the graphics. MATLAB allows graphs to be created quickly and conveniently. For example, to create a graph of the T and V arrays, the graph appears in the graphic window and can be transferred via the cupboard to the programs. Also, you can customize the graph a bit with a command. Next, we have to be explained M
Provides
files.
an alternative way of performing operations that greatly expand MATLAB's problem-solving capabilities.
An M files contains a series of statements that can be run all at once. It also comes into two flavors. First, we have the script files and the function files.
Script files is merely a series of MATLAB commands that are saved on a file.
Also, script files is useful for retaining a series of commands that you want to execute on more than one occasion. The script can be executed by typing the file name in a command window or by invoicing the menu selection in the edit window.
Function files. In constant contrast to script files, they can accept input arguments and return outputs.
They are analogous to user-defined functioning in programming languages such as Fortran and Visual Basic. Another subtopic of MATLAB files.
Structure programming. It is a programming paradigm that facilitates the creation of programs with readable code and reusable components.
It is the simplest of all the MATLAB files perform instructions sequentially. So this classified into two. First, we have the decision or selection, and second, we have the loops or repetition. First, decision. This structure allows you to execute a set of statements if logical condition is true. As for the loops, it is the same implies loops perform operation repetitively. There are two types of loops depending on how repetitions are terminated. First, a for loop ends after a specified number of repetition. A while loop ends on the basis of logical condition. So we have the another subtopic, which is the passing functions to MATLAB files. Much of the remainder of the book involves developing function to numerically evaluate others' function. Although a customized function could be developed for every new equation we analyze. Here the two ways and passing function to MATLAB files, which is the anonymous function and the function. So first we have the anonymous functions allows you to create a simple function without creating an M file. They can be defined within the command window with the following syntax. Second, we have the function. These are functions that operate on the other function which are passed to it as input arguments. Also, the function that is passed to the function is referred to as the pass function. A simple example is the built-in function. So next, we will move on in our next lecture, which is the random and truncation errors. So we have here the errors. The errors is associated with both calculations and measurements that can be characterized with regard to their accuracy and precision. Hence, accuracy refers to how closely a computed or measured value agrees with the true values. And precision refers to how closely individual computed or measured values agree with each other.
Randolph errors. It arises because digital computer cannot represent same quantities exactly.
Of errors is important to engineering and scientific problems solving because they can lead to erroneous result. Also, there are two major facets of random errors involved in numerical calculations. First, we have the digital computers have size and precision limits on their ability to represent number. Second, certain numerical manipulations are highly sensitive to random errors.
Truncation error. Those errors that result from using an approximation in place of an exact mathematical procedure.
Also, a truncation error was introduced into the numerical solution because the difference equation only approximates the true value of derivative. Next, we have here the total numerical error. Total numerical error is the summation of the truncation and roundoff errors. In general, the only way to minimize roundoff errors is to increase the number of significant figures of the computer. So next we have the blunders, model errors, and data uncertainty. Blunders, also known gross errors. Blunders can occur at any stage of the mathematical modeling process and can contribute to all the other components of errors. Also, they can be avoided only by sound knowledge of fundamentals principles and by care with which you approach and design your solution to a problem. Next, we have the model errors. Model errors is related to bias that can be ascribed to incomplete mathematical models. An example of a negligible model error is the fact that Newton's second law does not account for relatives effect. Lastly, we have the data uncertainty. Errors sometimes enter into all analysis because of uncertainty in the physical data on which a model is based. These errors occurs or can exhibit both inaccuracy and imprecision.